Hello everyone, in this video we will learn to solve a very interesting problem which is sort a nearly sorted array. In this problem we have been given an integer array and the k, right? The problem states that any element which is at which has the index I, right? After sorting it could be at most or far can go by I plus k or I minus k. Now what I mean by that is that let's suppose any element x is there which is right now at ith element, right? So after sorting it could either go up to a range of I I minus k or I plus k. Right. In this example, we can see, let's take an example of 2. So 2 right now is at the index 3. 0, this is 1, this is 2, and this is 3. Right. And we have been given k is equals to 3. Right. So this 2 is, ith minus k. So at this much far distance from its actual position, right? So actual position of 2 is 0th index, right? And from here it is at most k distance far, right? So this is what given to us in the problem statement, right? Now we need to solve this problem. So how to approach it, right? First approach, you will say that Sonu, we can simply use sorting, right? That will result in the time complexity of n log n, right? Which is correct, but it will give us time limit exceeded, right, for some test cases. Second thing in the problem which we can see is that we have been given a k, right? Okay, the k as an input, so this has been given to us. Another thing is which we can observe right now, that after sorting it we need to sort it on the basis of smallest element first, and then more largest, and then at the end larger element, right? So we are also getting these three observation by just seeing the problem, right? And we can see that these 3 points could result in the identification of a data structure which we learned in the previous video, which is heaps, right? Now, okay, you will say that, Sonu, we can see the problem is encouraging us to solve heap data structure, but what, like min heap or max heap, which one I should use, right? So in this problem you can choose any of this, but just remember the fact that if you will start from the beginning, then you need to use min heap because you need the minimum element first, right? And if you will start from back, then you can use max heap because you need the maximum element first. For this problem we will go by min heap approach, right? Okay, so let's again try to solve with another example. I can just simply remove this one. Okay, so you will say, okay, we will use min heap, but how we will simply try to reduce the time complexity from n log n to n log k. So in the previous approach, or in the identification of heaps, we learned that we just try to reduce the space of the complete binary tree from log of n to log of k, right? So in that sense is basically like the depth of binary tree got reduces, and so does it result in time complexity also. It results in lesser time complexity. So, okay, we can use only kth approach, right? Like we will create a priority queue of size k, right? We will append all the elements till the size k, and if we are getting any other element after iterating, then we will simply just pop it and push the next one, right? Pop it, like if we will pop it, then it will be the smallest one, and if we will just push it, it will be the next one. Now let's uh, go through this example, right? So initially what we did, we have k is equals to 3. So initially what I'll do, I'll just simply insert 3 elements, and it will come in this order of that, right? Don't consider it as a normal container, inside it is CBT, right? Complete binary tree. Okay, so 3 elements are inserted. Now after that I'll start iterating a while loop from I less than n, and now the I is reached to third index, like 0 1 2 3. Fine. So, and we have an incrementing factor over there. Now what I'll do is, I have simply the topest element is the smallest one. So what I can say is, I can just simply pop it and store it in my answer vector, So I'll simply store the 2, right? So I'll just, store top, then pop it, and then insert the ith element. This is the flow that we are going to use. Now you will say that, okay, Sonu, what we did, we insert the 2. Now 3 is there, so we just popped it or we inserted it. So 3 will be at the top after 2 went, right? And then 3 will be inserted back, right? After that 6, and then 7, in that manner again. But then now the thing is that 2 more elements left in the priority queue. So what do we need to do about that? And also, like before that, we have inserted I from 0 to 3 into the priority queue, right? That's why 2 8 10 becomes. But after this, like, we will more learn about this in the, while we will reach to the code. But for now, just try to understand that we are just trying to insert it at one go and getting the top element, which will be the smallest one. And once we get the smallest one, we'll just simply store it in the answer vector, right? That's all the complete approach, right? And after that, I will just check if my priority queue is not empty, right? If it is empty, then fine. If it is not, then I'll simply pop the all elements and keep inserting it, right? I'll just pop it, and I'll do until it gets empty, right? So that's how, we will try to solve this. Right, now let's go to the code, right? So this problem is available in the Geeks for Geeks. So we have been given an function which we need to complete. So I have created an answer vector first. Then after that, I have created a min heap, and inside the min heap constructor, I have passed the array till the kth element, right? I have done this k plus 1, so don't get confused that what is k plus 1. K plus 1 is basically, if you have some idea about, container initialization, then you will get to know that, okay, if this doesn't take the ending part, right? So if you will write k, then it will doesn't if it will not include k1, right? So if I'll write k plus 1, then it will not include k plus 1, so it will include till k, right? So I have just automatically, inserted all the elements from 0 to k elements. After that, I started iterating from k plus 1, because k plus 1th is not inserted, right, till n. So after that, as I mentioned, I'll just first, I have already, like in that example, I have 2 8 10. So I'll just simply put 2 in my answer vector, right? After that, if I just remove 2, then I will insert new element, which is 3. 3 8 and 10. It becomes like that. So in the next iteration, I'll just remove 3 and I'll store it here, right? And then again it becomes like, the next element which comes will be 6. So 6 is there, right? And then 7 is there. But after that, 8 and 10 will be left out, right? So till here my answer vector looks like this. But after that, if you can see this, right, this while loop, so I'm emptying the priority queue. I'm emptying the priority queue till all the elements left, right? So anyhow, I'm getting the top element, which will be the smallest, and storing it in my answer vector again, right? So, and just simply popping it down and then simply return the answer. So in that manner, I just simply, try to solve this approach. This is a very small code, right? If you can see, just simply inserting in the priority queue, popping it down, and it will also reducing the time complexity by n log of k, right? So this is pretty efficient for us, because initially we had n log n, right? And problem also states that we don't need to use standard sorting algorithm. So we also solve that, and that's all what it is, and we successfully reduces the time complexity. So that's all for this video, and I hope I add small value to this, and if so, then thank you so much for watching.